And so here we are with the last of 3 lectures where we're expanding on our GIS data attributes. And again, working with GIS data attributes within our tables here. First, we ask questions of our attributes. Next, we attached additional data to our attributes with our joins and relates. And now we're talking about expanding the data attributes ourselves. And so how do we do that? Well, we're talking about databases, and in a GIS database, like any other database, you may need to add to your fields. You may need to edit what is currently in your fields. You may need to calculate from a combination of the fields in your data into a new field. So that second point is really important, that you have to consider what you're going to be storing before you decide to add a particular field or fields to your GIS dataset. So really this lecture is basically a survey of these 6 different types of fields that you would add to your GIS data, and then towards the end we'll talk about briefly calculating attributes, and we'll see that in the demo in the final video of this module. So as I said, we're going to survey each one of these 6 different types very quickly, and just kind of understanding what the difference is between them and when you would use any of them. So a text field is designed to just hold text, obviously. As we say here, anything that is alphanumeric, anything that is descriptive information that is done with text would be held within a text field. But the second bullet there really indicates something that you need to be mindful of. Be careful what you put into your fields, because if you're putting in single quotes and double quotes into your actual text fields, in this case we're looking at a comments field that has lots of commas and dashes and those kinds of things in it, those can mess with your queries a little bit. If you remember, when you do queries, you have to put quotes around what you're querying for within a text field. So you want to be mindful of that, so that you're not returning something that is incorrect, or so that you're not just getting any kind of result from your queries. So fairly straightforward. When you add these text fields in, you just indicate how wide you want that field to be. Since we're using shapefiles, we're using a format for the database called DBF, as we've mentioned before. And so when you add in a new field and you actually go to name it, you are limited to 10 characters, and you don't want to put spaces. If you do want to have a space between your letters, you use an underscore. But other than that, any kind of odd sort of types of characters your fields do not want to contain. So ArcGIS will usually bark at you and let you know when you've put something in that you're not supposed to as a field name, or if you have made your field name too long. Now we start to get into the numeric types of fields. In this case, our first one is short integer. And as short integer indicates, or as integer indicates, these are whole numbers. There are no decimals. And what's really key here is that we're talking about using these numbers, even though they're mathematical values, they are typically used for smaller types of numbers, and you can use them for coding. So I use land use code here as the example. So we're just talking about a 2-digit number. We're not storing a very large number, or even a 3-digit number in the case of some of our Maryland land use codes. But again, these are nominal codes that are not meant to have any math done to them. So of course, even though these are numeric, we wouldn't do math to them, because they're just indicating something else, that the code number means some other type of nominal descriptive type of attribute. So in this case, we're looking at 41s, which are deciduous forest, 22s, which are some sort of agricultural operation, 21s in this case happens to be agriculture that is specifically cropland. And again, those are land use codes, so we're using that short integer value to store coded values. But when we start to decide to store quantities, such as larger numbers, for example, we would use a long integer. And again, those would be whole numbers, no decimals in any of these numbers. And I'll go ahead and pop up what I'm focusing on here in these slides. And they can be positive or negative, just like in short integer, but no decimals. So you can see that we're looking at that US demographics table that we used in our demo earlier. And so what I have circled here is our population for 2000, 2005. No decimals here, we're looking at whole numbers. And then the same thing with a lot of our demographics. Notice that pop 2000 square mile, pop 2005 per square mile, these are density values that are not using non-decimal whole numbers. So I did not circle them because they are not of a field type of long integer, excuse me. So again, when you're using actual measured amounts of something, quantity values, as I've underscored over here. My example in this case, of course, are population values, but think about customer spending or customer expenditures in some sort of a dollar amount. That could range anywhere from 0 up to any number that would be considered a whole number. Now, if you're considering in those customer spending fields dollars and cents, then you would want to consider a field type that would contain, that type of decimal value. And so you would not consider a long integer field. You would consider something like a float field. This is also a numeric character, or will store numeric characters, but in this case you can store different types of decimals. Now you see what I have circled here. We can store up to a precision of 6 places past the decimal. In the two cases that I have over here, these two fields, the perk 65 and up and perk 65 and up underscore, are float fields. So they have a decimal within them, and they have a certain amount of digits past the decimal. You'll notice that population 2005 and then age 65 and up do not. So these are actually long integer fields. But what perk 65 and up and perk 65 and up underscore show is basically the percentage of age 65 and up of the population in 2005. So what I've done with these two fields, they are different, and you can have repeating names for field names, so that's why I added the extra underscore here. But in this case, I've actually shown the actual decimal value of 9.3%, whereas in this other field over here, I've multiplied it times 100, which gives me the more commonplace or everyday user expression of percentage, which may be a little more intelligible to the average map reader if we were going to actually map these values and put them on a legend. So you can see again how you can use those different types of float fields to your advantage to show the same values in a couple of different ways. And of course these are whole number, long integer values. These are our float values. The key here really is the difference between float and our next type, which is double, is the number, the precision past the decimal places. In this case you can take a number that's as far out as 6 digits past the decimal, and so these are only going out 3. In this case we're only going out 1. If you're going to be looking at very precise, very large numbers, you would consider using a double field. So in this case, our precision can go up to 15 places past the decimal. And so our example here is longitude and latitude. If we're looking at these coordinates, we're looking at decimal degrees. These are degrees east and west of the prime meridian and north and south of the equator. So these are the kind of coordinate values that you may have used as part of assignment number 2. The earthquake mapping project. In this case, in my example, I am looking at 1, 2, 3, 4, 5, 6 places past the decimal. So this field may actually be a float rather than a double, but it has potential to be a double. It could actually be listed as a double, but we're only storing 6 digits past. But with a double, of course, we can store that out to a very precise number of 15 digits past the decimal place. And all along throughout this lecture, you see that I have referred to the Field Calculator Unleashed document. So a lot of what we see here is contained within our Field Calculator Unleashed document. This is one of the resource documents that I gave you, and I'm just going to scroll down here quickly, and it does show you how to interact with adding new fields, and you're going to see all of this in the demo. But a lot of what I just talked about is contained within this nice table right here. And one of the other things that we're going to talk about is the precision and the scale of a new field that we add. So again, using the lecture, using the video, using the PDF, using the resource document that I give you should be ample for you to be able to work with these tables in the manner that I'm demonstrating here. The last one we talk about is a date field, and really what's important is that ArcGIS has its own date format. Month, day, and then 4-digit year. So when you store dates in a date field in ArcGIS, in ArcMap, this is how it's going to want to store it, versus if you already have data that is in some sort of other format. In this case I'm using Excel, for example. It may be a specific date format, but if it does not match what is in ArcMap or what the format that ArcMap chooses, it will label it as a text field. And so that is something to consider if you're importing data from an external tabular source like Excel. So when working with numeric attributes, you got to understand the difference between precision and scale. That's one of the things that ArcMap is going to ask you when you go ahead and add a new field that is numeric in nature. So when we talk about precision, in this case, precision is indicated by this larger bar outside, and that's basically showing us the overall width of the field and what the largest number possibly is that we could store. So in this case, the comma is not part of the precision. So our precision would actually be, let me bring my cursor back in here, 8987, so that's 1, 2, 3, 4 digits. Decimal place is 5, 6, 7, 8, 9, 10. So my overall precision will allow me to store a number that could have 10 digits in it, including the decimal place. The scale is going to be, as this indicates, how many digits to the right, places, excuse me, to the right of the decimal you can have in a given number. So we'll see how this works when we actually create it within the context of the demo. But again, referring to the Field Calculator Unleashed document is really going to help you, and this same exact example is within that document. If we were going to do a much smaller number, say the largest number we would store is 999, so that would be 3 digits, or 999.25, then we would have a precision of 1, 2, 3, 4, 5, 6 with a scale of 2. So again, that's just an example, and we'll see that as we work throughout the demo. The last thing that I talk about here is calculations, and again, we'll do this in the demo, but I did want to point out that there may be need to populate one of your fields that you add with something that you, as the user, want to define. So you may want to tag all of your features in one shapefile of a certain value within a particular field. You may want to tag different ones or different groups or subsets, as our queries indicated, with different values. You may want to calculate one field with the value from another field so that you can then edit it. And then part of another field. There's a lot of functionality in ArcMap to basically truncate certain fields and allow you to only show part of one field or another. A combination of multiple fields. You may have 2 columns that have information that you want to join together into another field, and so you can do that as well. Mathematical operations, which we'll actually show an example of within the demo, but as you saw in the slides, you can also, for example, using our age 65 and up, divide it by population. That's normalizing our data. We can do that within the symbology tab, or we can actually make that permanent within our table by accommodating that value with a column. So we could actually add a column to where we divide one population by another to normalize it, and then we have it permanently in that data set. So you're going to use the field calculator quite a bit as you're working through doing your own calculations, and so the field calculator Unleashed document is kind of a funny name, sort of an intense name for something that doesn't seem, it's fairly unassuming, but it is a very powerful part of ArcGIS that allows you to control a lot of your attribute values. So as we say down here at the bottom, we're going to use the joins and queries demo one last time. Joins and queries, and of course calculations. Maybe I should add that in there next time. But we're going to kind of come full circle with several of the skills that we've learned over the last 3 lectures and these 3 demos.